Hello and good afternoon. How to migrate existing reactive forms to the brand new signal forms? This is the big question we want to answer today. And for this, my colleague Michael Eckertsikas has prepared a lot of things for you. Hi, Michael.
Hi, hello everyone. Nice to meet you all.
So the idea is we start with a presentation from Michael, and please feel free to put all your questions into the chat. We will pick them up during the Q&A at the end. Yeah, and after our presentation and live coding, we will look into those questions. So Michael, stage is yours.
Perfect. Hello everyone. Hi. This talk is about the new Signal Forms API. We receive it actually with the brand new Angular version that will be published likely next week, so Angular 21. Nevertheless, already the next versions and the release candidate versions that we can already work with shows a very nice and convenient API. Basically, I called this talk Signal Forms meets State Management because, we need to typically integrate the new APIs that Angular and also the third parties like NGRX are offering us. We need to integrate them into our existing applications. That's the challenge. We are, most of us at least, very excited about all the new APIs that we received and are still receiving. But at the end, of course, it's kind of a mission to implement this into existing code bases. And this is what I will also highlight in this talk and show you some patterns on how we could do this best, basically. Let's start with a very quick introduction about signal forms.
Michael, by the way, you have quite an echo. Can you check if the right microphone is on?
Yeah, give me a second.
The mic button below there. On the arrow next to the mic button.
Give me a second to try to put it a little bit closer.
Somehow it's quite an echo. It sounds like you are sitting in a huge, in a huge hall, in a huge warehouse.
Let me quickly try something out. Give me a second.
Yeah, this is the position within a workshop where usually we ask someone to tell a joke. So if someone knows a good joke, feel free to put it into the chat. Now you are completely muted. Still muted. Muted.
Double muted, sorry, it was the button. Is it better right now?
Not really, but perhaps we should go on that way. So I think we can live with it.
Fine. Basically, the Angular state management is a key for our Angular applications, and basically it is the Signal API that gives us already basic abilities to do so. But at the end, we often also have an enterprise state management solution like today the Signal Store integrated into our applications. Let me quickly show what I would like to talk about and tell you during this.
Now you are muted again. Don't know what's going on here. Okay, now you are back. Yeah.
Fine. Basically about the signal forms refactoring, and this signal forms refactoring should, for example, replace a reactive forms implementation that is part of your code base, and you can then also connect this somehow to state management implementation like the Signal Store. We also have some advanced APIs for the Signal Store like the Event API, so we will also take a look into that. And finally, we will discuss also solutions on how to link those two state management systems together and forms implementation, like today reactive forms, template-driven forms, but also an implementation like signal forms is already a state management API. It's a state management API that exists for a state at the a specific point of time of the lifetime of the state actually, as the user is entering and filling form fields until they get valid, and then at the end, if the state is valid, you would like typically to pre-process them or post-process them, put them into a persistence layer, typically your server, and therefore an enterprise state management solution like the signal store, but also maybe the resource API can be helpful to connect to your backend. Let me quickly introduce myself. My name is Michael, full name Michael Egertzikes, but far too complicated to pronounce. So therefore you are very invited to just call me Michael if we meet each other at conferences or somewhere else. I'm trainer at the Angular Architects and basically doing trainings, consultancies, and code reviews. If you like, you can also join one of my next workshops, which deals exactly about all the new modern APIs, reactivity, signals, and the signal store, and of course, also the signal form API. If you like, you can follow me on social media, also other Angular experts. It's always nice to chat about all the recent updates that we received in the Angular framework, but also in the ecosystem. And as mentioned, also take a look at our website for additional workshops that we offer for testing, for performance, and so on. Let's start now with signal forms. As mentioned, we already have a prototype. This prototype will become experimental with the Angular version 21. So that's the first time that we really receive an Angular package then that has a stable state, at least the package itself, that offers this experimental API. Afterwards, as we know it from other framework APIs, one day it will become developer preview and then later on stable. But it's a while to go basically until we can expect a stable state for the signal forms API. But already the implementation that we know right now is quite nice. It's quite easy to use, and somehow the mission was to take the best parts of the previous two implementations that we had, template-driven forms and reactive forms, somehow put the most successful and best APIs that we love to work with in the one or the other forms API into one third forms API, the signal forms API, that shall be compatible with the other form implementations. That means it will then also be possible to integrate a reactive forms child component into the metadata of a signal form or the other way around. First of all, this package, of course, has the aim to push the form state management ability into the world of Angular signals. Because until now, we could already use a forms implementation together with the signal API. Both were capable of integrating with signals, reactive forms, and template-driven forms. But to be honest, it did not always feel that nice. Yeah, we for template-driven forms we needed to create quite a bunch of writable signals. For the API of reactive forms, we at least needed an effect to read one signal and write it to the forms API by using patch value or also set value. So at the end, the signals API, signal forms API that we will receive now is 21, has a different approach. It has the approach to first use a data model. This data model is a writable signal, and this writable signal is connected with a form function basically to the API of signal forms. So this forms function can use your data model, your writable signal, and it adds all the known metadata that we are used to work with in the other form APIs like valid, dirty, touch, disabled, and even more today. So reactive ability to also set form fields to read only, to also hide form fields, and so on. So this is the field state. The field state wraps your writable signal and adds all the metadata that we need for the Forms API. Then we have the field logic. The field logic is optional, but very likely you will use it in quite a lot of form implementations that you have in your code base, because it brings you all the APIs for validation. As mentioned, to turn things conditionally into read-only, disabled, hidden. Hidden means we put a form field out of the validation, right? So it doesn't mean that it really hides your form field in the UI. Therefore, you can use normal abilities in the template, like if condition, a switch block or whatever. But it uses a hidden state semantically. So within your metadata, it can put the field out of the validation engine actually, or the validation runs that happen in your Angular application in your Angular form. And finally, we have a UI control. Yeah, we have a UI control, actually several UI controls that we work with in our template. And this UI control basically connects your TypeScript created metadata with the form function with the template subcomponents or normal browser text, like an input control, for example. And you put both into a synchronization state actually. So if the user enters something into the control, it is automatically synced with your forms metadata, but on the other hand, also with the underlying data model. That means automated synchronization between the form state and the writable signal. That's quite interesting, and that makes the whole story quite easy to use, right? Because actually we do not need to read the signal manually again to write it back into a forms implementation, like or use that state from the form to write it basically manually to the state management, the other way around. Use some signals that we have around, a readable signal maybe, and connect it into our Forms API. This is automatically in sync as long as you have a writable signal. We will come back to this point in after a few iterations of this webinar, where I show you different live codings actually. Then afterwards, we'll come back to this very question. What happens if you actually do not have a writable signal? How does it work then? So basically, template bindings with the controller, actually it was renamed to field directive. Fine. So let us take a look together into the Forms API. Give me a second to show this on the screen. Basically, here in my application, I follow some nice structuring concepts. I have quite a lean shell application with just a source folder and an app folder. Only those four files here. So the app component, the app routes, the app config, and this is something for generic navigation. So configuration file for generic navigation. And basically, we can then look into the libraries folder, because here we have the place where everything is implemented that is part of this application, our subdomains actually. So like boarding, booking, and check-in. And first of all, I would like to focus on the check-in area. The check-in area actually offers us some abilities to look up passengers. So by first name, by last name, for example, we can use our Angular Architect's demo API here, and I can click on edit. My passenger detail screen is opened now in an editable view at the moment, implemented with reactive forms, and Emma Smith is shown right here. We can also use some buttons here to jump to other IDs, and basically this happens already through the resource API. So in this application, the resource API is used. Give me a second to also show you the code. So here in the check-in subfolder, with the library subfolder and feature passenger edit. Here you can click on the TypeScript component. I hide my project tree here. And as you can see, we are using here at the moment reactive forms. So the edit form property here is actually created with the form builder, and the form group is created with an initial state. Then, as you can see here, we have modern inputs like a signal-based input that can be set by the router here. So the router uses a component input binding feature to basically can activate this. So just show this for a second. Can activate this here in the app config. Basically, there the provide router function with the app routes or app routes is used together with a very nice feature with component input binding. And that means actually, if there's any router state, for example, the dynamic argument here in the URL, at the moment 2959, yeah, that's the idea of this passenger. The router can directly look for an input in your component that has the very same name like the state of the router, so in this case the dynamic variable in the URL, and then it can basically exactly map that one back to the input of my passenger edit component. So here we have an ID. It's a signal-based input, so it returns an input signal. It has a default value here with the ID 0. So if no one provides the input, then at least it is type compliant, set to the number 0. And here I'm using a transform function. That's quite helpful because that way we can, no matter if the router is returning us a string because it's part of the URL, or the router is returning us a number because it's maybe part of resolved data or the data block in your route. No matter what it is, the number attribute function here tries to transform it to a number. This is what basically happens here. So my ID is reliably available here. The edit component uses an ID, and this ID can then, for example, with the new HTTP resource that we received with Angular 19.2, uses the HTTP client behind the cover. And here we tell our implementation here with this configuration object, please use this backend API and use some parameters. Use some parameters. One, in this case, it's the ID that comes from our signal-based input. And if this ID changes, then also the HTTP fetching happens once again. We have a default value here. Default value is quite helpful to have on one hand an initial value, but also have a value if, for example, one ID is loaded and you want to navigate to another ID. And that's, of course, a latency that occurs. So the new ID, the new passenger, needs to be loaded over the wire from our backend API. And in between, it switches to the default value. Let's see if it stays that way. It would also be nice to have a configuration option in future where we could decide on our own whether we want to keep the current passenger displayed until a new one is available, or whether we want to have the current default behavior of switching back to the default value, which is the initial passenger in my case. That way, as we navigate around here, you can see it like that, for a very short moment of time, actually the latency of the server, we have the initial state assigned and written to the form, and then it switches back to the new state that was returned by the server. So basically that's the implementation that we have right now. We're also logging something to the console here with an effect. And at the moment, because of reactive forms, we also have kind of the need to connect the resource value signal back to the reactive form. Otherwise, nothing would be shown on the screen, right? And we would like now to transition this to an implementation that uses the Signal Forms API. For that, first of all, because I'm using VS Code and VS Code has issues finding new packages like the secondary entry point here, I use my package here add Angular forms /signals. And here you can find the form function, and the form function can be used down there to replace basically that implementation. Yeah, so I really assign my form function here knowing that, of course, at the moment some parts are breaking, but we will fix them, of course. And to start with, I would like to create just a normal writable signal. So I use a passenger here, and this passenger is of type signal. And this signal has a specific type defined. It's the initial passenger, all right? So that's the normal way, maybe the first signal-based API that people typically come into contact with creating a writable signal. Today, we also have other options of creating writable signal. One is also the resource itself. So first of all, I want to show you a very basic, a very essential signal form implementation. And then afterwards, we will also switch to the writable signal of the resource again. So connecting the kind of current state, how the component is at the moment implemented with reactive forms. So first of all, here this form wrapper expects to receive a writable signal, and that's actually what we did the line before. So I can directly pass this in, and I can also add some comments to give you a little bit more context. So this is the first step. And here we are creating a data model. And this data model is always a writable signal. So in our case, really the normal signal function. Then we move on to the second step. What is the second step? Basically, it is, oops, sorry, not creating emojis here in my comments, maybe. So basically here we have the field state. And this field state is typically the metadata that you expect working with the Forms API. So in this case, it is, for example, valid, it is touched, it is dirty, it is the value itself, of course. It is also read-only and disabled. Fine. So quite a lot of, even more actually, but some of the possible properties that we have in the forms metadata. Fine. And this is already the most important part for implementation. There's also a step 3 actually that I will leave out for the moment, but show you in some minutes. And I directly jump to the step 4. And this is now my control directive. It is renamed then with 21 to field, but actually the idea is the same. We have a directive that we can import. So basically it's about our UI control, or controls actually, or the UI controls that you want to connect. And it is basically about the template bindings. Yeah, you use this very directive or field with 21 and with the stable release that will be available very soon. And that way we can connect it in the template. Fine. I save it for a moment and then return back to my template HTML DOM here. And basically, as you can see, we have currently reactive forms connected. I will delete this part. And reactive forms also uses the property form control name to basically select the specific property that shall be connected with a specific input field. And already in reactive forms, we have an API ready that knows how to read and to write back to the metadata. Same idea here for the signal-based forms API. And here we can use control. As mentioned, in future versions, you can then use for that the field directive. And here we can connect edit form dot ID. Fine. The rest can stay the same, and I will copy this part over to the other controls. And of course, we can use also code completion. So maybe I copy that over for the following fields to be a little bit quicker. And here we have the first name already directly with code completion, right? Because it's just enough to have proper typing for your writable signal, and this typing is then also available within the definition of your signal form. Fine. Here we can use copying error. Sorry, once again, hit the wrong shortcut here. Fine. And here we can use edit form dot and name is in this case the last name of the passenger. Then we continue with the bonus miles here. And finally, down there, we have another form control, passenger status. Fine, that's all for the moment. Down there you will find some error messages and so on. I will just comment them out for the moment. Later on, we will take a focus back on this again. And down there, you can also see that the validity plays a role here. So we want to disable the save button if the form is not valid. Be aware, not valid, like with the current form APIs that we know, not valid and invalid is not the same, because a state can also be pending or disabled. So in this case, I need to fix this a bit and just call the edit form here and valid. We have quite a lot of signal-based APIs, of course, because it's signal forms. So we are fully reactive. We can read the state and the value and all the other informations we are interested in with signal-based reactive access. Fine, let me take a quick look if there's something open that we would need to patch. No, it looks good. Then I turn back to my TypeScript class, something down there. Yeah, of course, my effect is not necessary anymore, right? We have no reactive forms implementation, no need to patch a signal into a form metadata so that the value is then shown inside the form, or is available first in the metadata and then the metadata is connected with the template. Why is this not necessary anymore? Why can I really delete that part? Because our state comes from the writable signal. This writable signal is actually the initial reference to create the form metadata, and it's synced in both directions. Yeah, that's the nice thing about this new API. I can also get actually rid of the whole constructor, because logging out the ID is just for demo purpose to demonstrate that the signal read works. Down there is one remaining part. We actually use the value to set it back to the resource. I can comment this out for a moment and just focus on the console log here. So if we click the save button, basically it shall lock the value into our console. So that's what we can do right here. Fine. Okay, then let's take a look into our implementation. It's the passenger edit. At the moment, the data is not hydrated, so it's not read from the backend API, although the resource is still here. But at the moment, the resource is not connected to our forms API. That was the first step, right? So we show the initial passenger here. But what we can already do, I zoom a little bit in here in the console, I can enter here something. So maybe my name first. And then I can click on the save button. And as you can see, the data that I entered here into the form was directly also written into the metadata of the signal forms API and basically back into the writable signal. That's what we can see here. Basically, I just showed you the way of the edit form. But of course, we can do a second console log, and this time just use the passenger signal itself, and then we can figure out whether it is really the very same data, Michael, and my last name, the complicated one. And then I click save and everything is synced, right? So really twice the same data that is here available, once directly out of the metadata, another time, really using the data model that we use behind the covers. So that was the first simple refactoring from reactive forms to signal-based forms. I will do a quick commit in between. Give me a second. So let's call it Refactor RX forms to signal forms. And that's basically the essential part. Now we want to focus on also replacing the writable signal with my already present HTTP resource that has a value, and this value is basically already a writable signal. So why not using it directly? So let me quickly put this a few lines higher, so like this. And then we can swap out the passenger with my passenger resource dot value. And be aware, like before, we are just connecting the signal reference. We're not reading the value here. Because sometimes in the signal API, it's about reading values. Sometimes it's about signal values. Sometimes it's about passing in the signal reference. Here, we are talking about passing in the reference. Fine. I save it here, and then we can go back, and you will find now a UI that already does exactly what it did before, before the refactoring started. It shows the current passenger. The passenger can be found because my component knows about the ID that matches the ID in the URL, because the component input binding feature of the router was activated. And as the resource is bringing back my value, so the response actually returns the data that the server knows about this passenger, it is automatically written into my form without an effect directly in your code base. Although the resource is using an effect behind the covers, we don't need to register any effect in our code base. It's just a writable signal. This writable signal is connected at the end with your template. That's quite nice. And now let's demonstrate what happens if we change the name Emma to maybe Mary. And then I click the save button again. And you can even set the state to local here, or you can see that the state was set to local here because we are writing now back directly through our user input into the resource. And if the resource is written locally, the state changes from resolved to local. Yeah, so I hit the save button. And now if we look here into our console, you can see first name Mary, last name Walker, and nice thing, as we're not using the passenger signal anymore, the passenger signal has still the same state of the initial passenger. Yeah, we don't need the passenger signal anymore. It was just for demo purpose for the very first live coding, so I can remove that line of code and also this one. And by jumping back, you see the data to the resolve that comes from the server. We can click into the field, change something here, the form becomes dirty with the first keystroke, and my name is entered again, and the state is local. Yeah, hitting the save button now locks it to the console. Unfortunately, it cannot write back to the server directly with the resource at the moment. Yeah, you can implement this with third-party tooling. So Manfred already showed some nice webinars about this with the NGRX toolkit with a custom extension for the signal store, for example, where you can basically also use an extended resource concept, the mutation API, to write back to the server. But this is not part of this talk right now. So if you're interested in that, definitely also check out past webinars or the future ones where Manfred and my colleague Rainer are showing that concept. We will stay here with the Signal Forms API here, and I would like to show you some further usages. Yeah, some further usages of the Forms API, because I promised there is one missing step that I did not talk about until now. It's the step 3 actually. Yeah, step 3 is about the whole validation part. And so let's take a look on how we can implement that. And for this, I create a new constant. That's a schema. And this schema actually expects a lambda expression. The schema can be imported from the Signal Forms API, so the secondary entry point at Angular Forms signals again. And here you actually need to specify a lambda expression with an implementation body. And I call this the passenger path here, because we're talking about the path definition for our form where we can get access to all the form fields. And here we do not directly return a dictionary or directly a value like with computed signals. In this case, we really have an implementation block here. Yeah, so we can really write our code into that. And there are already some prepared validators that we can use, like required. And it works like that, calling a function, and then you can use the passenger path. Yeah, I forgot one thing, of course, the generic typing passenger. Yeah. And then you can use the passenger path here. Here it is. And we can directly now reference our field. So basically the one that we would like to turn into a required field. So that's a built-in validator that you can use that is directly provided by the framework. And we could, for example, say the last name, that one needs to be required. Then a semicolon follows. So not a normal comma here, but a semicolon. Because in the next line you can specify other validators. So if you want to turn also the first name into a required field, it works like that, right? That's all. Then we take our passenger schema here and can directly use it or reference it here down there as a second argument. So that's where the passenger schema can be used. And then I turn back to my HTML. And I also promised you the out commented parts here can be made available again. So it's about error messages in this case. It works a little bit different though. So in the past we had here, I leave it in the code so that you have a direct comparison for a moment. We had a reactive form success and we could use has error to basically check for a specific error key. That works a bit different here because here I'm using a loop, a for loop, and inside that for loop I can iterate over an array of errors. So I say my specific error can be fetched from the, or can be accessed from the edit form dot, and then I use the specific field where I want to display an error form for. Let's I start with the first name. Yeah, let's put it maybe here because we added the required validator here. And here we can use the first name, last name, both is used at the moment with the required validator, edit form dot name. Give me a second. Seems to be something broken with my code completion. Just a second. Should be possible that. Just give me a second. I add my track information just to have it completed. Track and track my error. What kind? No. Maybe adding an error message. Give me a moment. Just seems to be my template seems to be broken at the moment. Code completion. The column is wrong. Sorry for that. I added the column like in the past. Sorry for that. Now it works. Yeah, it's a bit tricky. Sometimes use the form directive if the structure is not 100% correct. You have the no underlinings. So now it works actually. We're using our metadata form variable. We are using a specific field of this metadata, like in this case, the name is the last name. We create that signal, and then this signal also exposes some additional information like the errors array. And the errors array is this time not a dictionary. Like in the past, we could use with RX forms, for example, an error dictionary where we could directly access the error key either with has error or even with the index signature. That works a bit different here because it's instead of a dictionary and array. I would say advantage is you can iterate over that with a for loop. The disadvantage is if you want to pick up a single error, it's a bit more complicated, I would say. So in this case, I say I'm iterating over all those errors. I'm using the error kind. The kind is basically the key of your errors, in our case here, required. And then we could either implement a switch case statement, or we could also use an if block here. I start with an if block first, and here you can take your error dot kind, and you can directly do a comparison here and check for required if you want to have a specific message for the required error key. Then I put it here. And then what I would like to show here, let's get rid of the unused instructions or messages here, and I just want to tell the user the name or last name field is mandatory. Please enter value. Fine. So let's save this. Then we can return to our template. And let's delete the last name now. And you can see the error appears here. Yeah? That's one specific way of implementing the error handling. Of course, you could also think of maybe if each and every error that is added to the metadata has an error message already, you could also simply ignore the if statement and just iterate over all the errors and just always log out or show the error message on the screen. Yeah, that's basically a simple validator like we can do it here with the required field. But I would also like to show you a bit more complex validator. So let's take a look into this as well. Still, we are using our schema here. Then I use the validate method. So the validate method is now for custom validators, and I can use again my passenger pass dot. And let's pick again my last name. And here I can add a lambda expression again. And typically you're doing a deconstruction or destructuring the JavaScript. That means you receive a variable here into the lambda expression that holds some of the properties. And the one property that I'm interested in, because you can also access, for example, the field status, you can also access the other fields, not only the name, but maybe additional fields like the first name, the ID, if this is relevant for you to calculate a validation result for the last name. For that, you maybe also need to check some other parts of your form data model or for your form state. Then it's also available as a variable inside here. But first of all, I would like to focus on the value. And the value is actually now the last name that is entered, and they could implement a very easy validator with just an if statement and say if the value equals Smith, that is what is shown initially in our form. Was it Smith actually, I guess, right? Let's do a reload. No, it was Walker, because I already iterated the IDs, right? Walker. The initial one, I guess, was Smith. And then I can return something. So maybe Walker is the value that is fine. So we could also check if it is not Walker. In this case, we want to return the custom error. And here we could add a kind. And this is basically, in our case, the last name validator, or validator is not a nice name, last name. Allowance value, no, last name check. Let's call it that way, just for the moment. And now I add a message. And basically the message can give some additional meaningful information to the user that we can then afterwards also use in our template. You saw the iteration over that error message, error object already, and show it on the screen afterwards. So in this case, we could just tell the user, please enter a valid last name, currently passengers need to be called Walker. Funny error message. Fine. Okay. But we have something now with our validator to show afterwards on the screen. Yeah, here we have a signal, of course. So that's why it is underlined at the moment. I was just using the reference here, but actually the value is a signal. So you need to access the value. It's reactive again. So that's the nice thing. Everything that you implement inside this API might be reactive depending on how you use your APIs. You know, we have an untracked function if it shall just be a one-time read. But typically having all those signals around here helps us to really have a reactive API. Yeah? And the default could be to just return null. Fine. Good. Then I would like to switch back to my HTML template. And here for the last name, I could add another if or an else if. And just check another kind. As mentioned, you can also implement a switch, of course. That would also be fine here. And I basically use my last name check. Was the arrow key that I used. And if you like, and already have a ready-made message for that, you can use error dot and directly the metadata. And you know, message is part of that metadata, so it can directly be used here. This time, this is not a signal, right? This is just a normal property that you can access. But the error itself, as you can see up there, is the array of errors is actually already reactive. Yeah. Fine. And then we go back and enter something else, but not Walker. And then we get our new error message here. Please enter a valid last name. Currently, passengers need to be called Walker. Fine. So it works. That's the usage of a custom validator. This API allows even far more, right? It already has features that are, I would say, offer you additional benefit compared to reactive forms and template-driven forms. That's quite nice. And what I really want to highlight, what we did actually at the very beginning of our refactoring, we just used a writable signal, and the writable signal can then be quite complex. It could have nested properties. It could be actually an object, like in our case, a passenger, and could have nested bookings. And those nested bookings could expand to different flights with all their detailed data. So whatever you want to model for your form data, the Signal Forms API has you covered, that it knows on how to update that data model in the correct way. And in the correct way means for the Signal API also immutably. So that's quite nice, because if you think back to template-driven forms, also template-driven forms is capable of writing back with engine model to writable signals. But at the end, you need a writable signal for each and every control, or at least you need some generic logic. There are some ideas with concepts with directives, so that you need to add on top of the Forms API to get a convenient user experience or developer experience actually for signal integration with forms. And here, it's really automatically available as a data module model as a writable signal that is directly wrapped and with the Forms API and creates your metadata that stays in sync no matter which part of the data model is changed. That's quite nice. Okay, fine. Basically, I would now like to jump back to my slide deck because I promised you to also give you a little bit of insights to the signal store actually. And the signal store is one lightweight concept that we can use to implement basically state management for our applications. Basically, the API was built around the ideas with some role models out of also the general JavaScript ecosystem, not only Angular, also a library from the Vue ecosystem, also the component store that already existed in the NGRX namespace was kind of a role model for the signal store. And at the end, a very nice API was designed that is also in some parts you will find similar ideas like for provider functions in your app config that were introduced with the standalone APIs. So how does a signal store look like? We have this wrapper function to create the store, signal store. Then you could optionally add some information where to provide this dependency injection provider, for example, on the root level. And then you can add features. So like we added the feature for the router previously for component input bindings, you can add a state definition like this. We can also add a computed state. That means derived state can be added and uses the computed API of the framework behind the covers. Then we have some methods that we could implement. Basically, the methods could either be an interface into your store to trigger some data loading logic, but you could also, for example, create methods to update state, passing in some state that you have available because of user interaction, for example, and add this into your store. That's not a side emoji, that's just a parenthesis to close my store implementation, right? So, fine. The signal store is a normal dependency injection provider. That's also the reason why we typically choose to use a capital letter for the constant name here, because that's like a class definition that you would do for your add injectable class that you can also provide on a root level. This time we're using the custom local store here, and you could put it basically into any provider array. It could be the app config. It could be a provider array inside your routing configuration, for lazy loading purpose, for example. It's also fine to use the signal store on a local level. Local level in this case would mean local state management inside your generic design system, for example. I make a pause here because is this really a good idea? Is it a good idea to use a store implementation, enterprise state management implementation for your generic design system? It can be actually, right? Because the signal store is not 100% comparable to the global store, like the NGRX store. It's also not 100% comparable to the component store. And they had different use cases where they really shined. Basically, the component store was good for isolated root state or even for local state management. That could be implemented in the generic design system. But on the other hand, the global store, you would likely never use the NGRX store dependency inside the generic design system. But you can do so with the signal store because the signal store can really span across your whole application. It can be used for global state management. It can be used for a group of smart components. It can be used for a group of UI components or even for a single component of your choice. And where you actually provide the store then determines which parts of the component tree can also access that store. But even more important, it also determines how long the store instance lives. If you put the store instance into a provider of your component basically, and then you navigate away from that component, the store instance would be destroyed, right? So take a good decision if you want to work with global state management, of course, it's a good idea to put it either in the app config or just use provided in root, like shown above as an optional statement here, optional configuration. Or also a lazy loaded routing configuration could be a nice place for your signal store, because that's an environment injector. I put it on the screen for a moment. So what I'm talking about is basically our routing configuration, like here. The app route could, for example, do a lazy loading. In my case, it's delegated to my library here. And this library holds a booking routes array. And this booking routes array is allowed to have providers. In this case, I'm using the NGRX global store here, the NGRX store. But it could also be your signal store provider that is provided here. And then it stays active and the instance is not destroyed, even if you navigate away. Because what a route provider actually creates is an environment injector. And an environment injector lives as long as your application lives, or someone destroys it programmatically, but this doesn't happen that often, right? Instead, the component provider would basically be destroyed quite often normally, routing away from the component, or for a child component template, an add-if or an add-for could destroy your component instance, right? So basically, we can quickly implement such a signal store instance into our booking folder, for example. So here I have my logic folder, and the logic folder could basically get a new file into its state folder called booking.store.ts. Here we could create a new booking store. And this booking store uses Signal Store API. Same reason like before. First import in this area to my Signal Store. Therefore, our VS Code is confused like always. NGRX signals. And here I can use the Signal Store. Fine. And here I can define some state. So let us quickly do this. I just say create a state with the with state function that can directly be imported from the signals package as well. I define an object here and I say I would like to manage some filters. I just do it inline right now. You could also put it into an external variable. Everything is fine. And then I say, hey, let's fly from New York to Paris, for example. Hope to have flights available on our API for that. Otherwise, we switch it back to another filter. It's not urgent at the moment. So we still have half an hour left, right? So it's not urgent for us. And here I add a basket, a shopping basket to select some flights. And they are basically a dictionary. So I could use some IDs here that are pre-selected, 3 and 5, for example. That was wrong that way. And each and every other ID that is not directly referenced here is then falsy. Yeah, so if I access this, it would be falsy. What's important here, that's only one option. As mentioned, you can also add a typing here with generic information, or you can put this into an external variable and just reference the variable here. All of that is fine. I just do a quick live coding here. And what's important for me right now, the basket. If I hover over that, TypeScript says, hey, that's an object with an property 5 that is a Boolean, and it's also possible to have a property 3 that is a Boolean. But at the end, this is not a dictionary like I would like to have where I could actually add any number in the Boolean state. So therefore, I do a typecasting here and say this is a record, TypeScript records, and let's say that's a number and a Boolean. And then it's nicely typed, and now I could add any additional property of type number in future. And finally, I would like to add a flights array. And it could be an empty array, and also do typecasting here. Typecasting is, by the way, not required. We can talk about this in more detail afterwards in the Q&A session. So you are free to also choose explicit types and avoid typecasting if you don't like that. what would be understandable, right? Fine. Then I add a with methods block. And this methods block can read everything that is currently implemented in the store. And I say, let's give me a load flight method, load flight method actually. And I would like to pass something in or create a function here where I can pass in a flight filter, and the flight filter is then afterwards used inside my implementation block to do something. Let's say fetching data from the server or whatever. I copy this over, and here I say I want to use the signals package still, but the RxJS in top. So like with the Angular core package, the NGRX team already tries to put RxJS dependencies into a secondary namespace. Why? Because one day we could have Angular with optional RxJS, and then you are in charge to decide whether you want to install RxJS or not. And if you don't need it, you do not import from that secondary entry point, and then your package JSON also doesn't need to have RxJS installed. So here I would like to use my Rx method, and this Rx method can be used down there. And I specify a typing here, so I expect to have a not filter, sorry, flight filter is the correct name, a flight filter available here. And then I would like to use some operators. And as I can expect now that a flight filter is passed into this operator chain, I could, for example, use a switch map. And this switch map can read my filter. And then I could say, I want to do a data access. But likely, don't implement data access directly into your signal store. It's better to have a specific data access service, still also with state management, because otherwise the signal store has too much responsibility, right? So we can do it either by adding it here as a second argument that is passed in, or another option would be to add a with props feature, because that way we can again read everything from the store if even needed. Yeah, in my case, here it is not even needed, so we could also do an empty parentheses afterwards. And I say I would like to use my flight service here. This runs in the injection context. That means I can use the inject function here and just access my flight service that way. And now we have an additional property that is available on the signal store. And the nice thing, you can even decide to turn this into a private property, yeah, with an underscore. That's all you need. And then we can directly use our store here, store dot, and you will find the flight service. It's now not part of the public signature. And we could say we want to look up some flights, and I pass in here my filter dot from my filter dot to and my filter dot origin. Fine. What is now returned in the success case is not a filter anymore, but this time a flight array. That's the signature of the find method, yeah, observable of type flight array. And then I add another package here. It's called signal or NGRX operators. And here I have a tap response operator. Yeah. The tap response operator can be directly chained onto the observable of the find method to have the correct spot if an error occurs, that you catch it early enough. And then here inside, we can use our tap response. Tap response is an operator, as you've seen from the NGRX namespace. It's kind of a wrapper around some nice RxJS APIs for managing a side effect with tap. On the other hand, also doing an error handling like with catch error, and that can be done like this. So we could say in the success case, some flights are returned, and those flights, different signature, of course, that way. Next method, so in the success case here, of course, some flights are returned. And then we need to decide what to do. Either you have already inside your store implementation update function that knows on how to add flights, to your signal store. If not, you can also directly use the patch state function here. You say, what do I want to patch? It's the store. And then we say, how shall the store change and produce a new state? As you can see here, it's really called patch state. So patch state means it's not necessary for you to provide the full state interface. It's for the at least first layer of your state, like where we have filter, basket, and flights. Here, it is fine to just use a partial state. And this is what I would like to do here. I want to change my flights property. What do I want to assign? I want to assign the flights variable name here, and if both have the same name in JavaScript, we can also get rid of that and just use the shortcut syntax like this, right? And then automatically the flights are overwritten by whatever the server sends to us in the success case. And here we have the error case, and now the signature looks nice again. So if an error occurs, I just say console without typos this time, so error, and I pass in my error feedback from the server. And the nice thing here, the tap response is not like an error callback in your subscribe, because that would stop the stream. In this case, it's like a catch error. That's the power of tap response. Yeah, the next processing and the error handling inside one operator. That's a bit less to write compared to the full APIs that we could also use. Fine. So that's the simple signal store, right? We could use this in our component to basically maybe also set the filter. So let us simply also use a set filter function that we could add here. The set filter function here could pass in a flight filter. And then we could use something like a patch state again and say I want to update the store with actually this field again, the shortcut syntax, that's all. Then you have two different flavors of methods here, one with a side effect that at the end also writes and updates your state, and one state altering function all alone, so the state updating function. All of them are working immutably, so that's the important part. And as I told you before, the store is not used here, so we can also use empty parentheses. That would also be fine. Yeah, that's a store implementation, a very simple one, right? I will also switch back now to my slides to give you a little bit more insights of what's also possible with a signal store. For example, of course, we can use it somewhere. Yeah, we can inject it somewhere. Keep in mind, it's important to provide it either on the root level or in a provider's array. And that last step here is then done in my component again. So here I have my flight search component. I can quickly use the TypeScript class property implementation store here and just inject my booking store. I guess I need to export it, right? I forgot about that. So let's pick the closest file here. And now the state folder is already exposed. Then I need that one. And here I basically export my booking store. Then it should be available with a nice import structure here. So booking store from flight logic or logic flight. That's the instance that we can use right now. I just use my present constructor here. And here I say this dot store. And now you can find everything that we have already registered here. You can find the basket. The basket is actually a signal, also it can return the state dictionary with which flights are selected actually. But what you can also do is accessing the filter. And the filter, if you have over that, it's a deep signal. A deep signal means it offers you signals on different levels of your object hierarchy. So you could potentially read the filter here, but it's also perfectly fine to not read the filter here, but just access the property on the deep signal reference and only connect to the from value, because that's likely in some areas more performant, because if the filter changes more frequently than the from property only, then basically it's beneficial to just
register on the from property itself, right? No need to create your own computed signal. This is automatically done for you. It's created for fully typed objects with nested state that is also object-based or a primitive like a string or number. It stops though on a level of like a dictionary, so I cannot read the single IDs of my basket as a signal. I can also not read directly an item of one of my arrays that are signal-based, but at least for objects that are fully typed, this works. That's quite nice, right? Beside the access of the state, because those are readable signals, I could also access my methods like before, so my load flights method. And if you want to use that flight method, actually, look at this very nice signature here. Load flights offers you to pass in either a flight filter directly. Then it's a one-time access. You just say, let's call this load flight function. I pass in the flight filter. Let's do this, just a simple try. Yeah, I would like to inform my store that I want to look up flights from Paris to Graz, for example, and it's not urgent at the moment. And what would it do actually? It would, at the time of the construction of this component, of course, you could put it into a search function or somewhere, right? It would basically use that function. That function would then, if I jump back to the, give me a second, not that way. Fine. If you jump back to the implementation here, it uses then the operator chain of this signal store with switch map, tap response, and so on. And basically, what it at the end does with the help of the flight service, it does a server call and it reacts, as we discussed before, on success responses and error responses. That's quite nice because that actually at the end updates your flight state, if it is successful at least. And that would mean if the flights are updated, of course, anywhere in your application where the store signal for the flights is used, everyone that is reactively connected to that signal, so a template, an effect, a computed maybe, they are automatically informed if the flights change. So that's a perfectly fine reactive implementation. But that's not all, right? Because the very same function like this dot store dot load flights, still it wants to receive a filter, but the other possible signatures are an observable of type filter or a signal of type filter. And now we are also reactive if it comes to the information that we pass into that function, right? It could be a stream of flight filters that where the stream emits the filters over time. It could be a changing state based on a flight filter signal that changes over time, right? So basically, if we look into our component here, we already have a filter signal. It's a writable signal. That means if anyone changes that writable signal, maybe it's changed because of user interaction of signal forms or whatever, then we could automatically connect this back to the store. And that's where the circle closes, right? That's likely a very nice approach where we can be reactive on the side of reading states, but also on the point of time where we want to trigger like an asynchronous side effect, like loading flights here. That's quite nice, right? So very, very convenient and easy and nice to use API. It supports all the three signatures: the type, observable of the type, and signal of the type. There's also already another method available, the signal method, and this is then the same but without the observable signature for a future where RxJS could be optional, right? Fine. So again, if you have then a signal that you want to connect into this load function, that's already where signal form again can help you providing that state for it. Good. What else is possible? We can also use the NGRX Signal Events API. That's really also quite nice because it can extend everything that we just discussed for the signal store with a event-based API like we use it in the Redux pattern, but also in the Flux pattern. The difference is just that you have only one single store instance for the Redux store concept, and you have several store instances for the Flux concept. Yeah? It's at the moment experimental, but very likely will become stable in the next release, 21. So it implements the Flux pattern close to the Redux pattern. It knows on how to manage state and side effects and reacts on events that you dispatch. On the other hand, you read still, like with normal signal stores, the state based on signals. And you can use the full power of angular dependency injection. You can provide a store depending on the lifetime, as we discussed before. It is maybe also destroyed in between or kept alive during the whole lifetime of your application. If it is part of an environment injector, you can inject the store, but you can also inject events. And this is kind of a decoupling, right? So if you want to trigger something, and it shall be triggered not only in one store, but in several store instances, because you might manage your flights in a different store than your passengers or tickets, right? And that way you could just dispatch one event, and different stores that have the need to react on this event could take action. Yeah, that's basically the idea of that. Let us quickly also show on the slide here with a nice component tree the architecture of such an event-based API. Between your components and the other layers, the logical layers behind, you have a central dispatcher instance. There you can dispatch events that are then received in different store instances, like the booking or the check-in store. So each of them might have a reducer implemented, like with the global NGRX store, same concept here. Behind the reducer, there's a state tree that is actually exactly that what we just implemented with the lightweight store. So just a state that is then available as a signal graph, actually, with different signals that are managed by the state. This time with the event API, only the reducer is allowed to update the state. Typically, at least you implement it that way, that the state is then directly updated by the reducers only, but not directly with patch state. And moreover, this is of course a single immutable state tree, not to forget about that. And you basically can read that single immutable state tree by just reading signals. So that part is the same like before. And if I switch back here and show it again, right, you can see you're directly reading the state out of your store instance, right? It's not any dispatcher, it's just the store instance itself that offers you the signals for your state. And then you have even furthermore implementation details for the side effects. So like the reducer API is available in the NGRX store, it's also available in the signal store, same for the effects. Yeah, so the effects can then also react directly on dispatched events, and that way it's quite coupled in a very lean way, in a very lean manner. And this is of course something that scales quite nicely, right? Those side effects could load a flight, and those side effects could then also manipulate the state by dispatching a new action, right? So if the load flights or the safe flight is successfully did the operation, it dispatches another action through the central dispatcher, and then again a reducer, for example, could jump in to update your state. How does it look like? So here I have actions for check-in again. So for the passenger area in my application where we implemented the signal form, we have a passenger filter changed action. So you always try to use names that are not commands, more events. So you just want to describe what happened in your component, for example. The user changed the filter, so passenger filter changed. Or the array of passengers was changed because a server responded. So it's also always a defensive way of doing the communication. It's not giving instructions on this shall be done. That's not the way on how we work with the passenger, with the Flux or the Redux pattern. Fine. And here we have the signal store. implementing exactly the interfaces of the Events API. So for example, with the with reducer function, you have some on statements included. And basically, you then react directly on the passenger changed action. You can read a payload like this here, and this payload then can be used to update your state, even with some additional nice features like the entities feature, where you can actually process collections, like typically a flight array is in reality, in practice, not managed as an array, but as a kind of optimized object where it is easy to access single flights with a flight ID, but also capable of updating a whole set of new flights. Yeah, with that, for that you can use the entity feature with the set all entities function here. There are furthermore functions available that help you to do all the CRUD operations on your entity-based data. Yeah, you can use this also together with the Events API. This is how a side effect might look like. So we have a signal store that has again this the passenger entity managed, and you have a with effect feature. This with effect feature can then basically process some events or listen to some events, like in this case, passenger filter change. You can see the on statement here, and then you delegate or you use again Rx operator chains, Rx jazz operator chains, and again we can do a server communication passenger service.find, and instead of the tap response that we used before, here we are using a map response. The map response is actually then transforming data. So it's not like doing a side effect like with tap. It's now using the map operator behind the covers. That means we are returning something from that operator chain, and what we actually return here is actually typically a new event. So in this case, the passengers changed event. And that's the way how the circle repeats. Someone can listen to the passenger changed event, another side effect, if you like, also a reducer to update the state. And that's how this pattern connects different tiny responsibilities of doing a single job. Yeah, loading data from the server as it is finished, either the state is modified or state is updated or an error is processed. You could do the same for safe operations. You could, of course, also do this without server communication. So having a side effect that writes to the local storage, for example, and reads data after the application was reloaded, right? All of that is possible in a very nice message-based manner, like with the Events API. Fine. Yeah, how do we dispatch actions? We can then go back to our component level, use the inject dispatch. The inject dispatch actually can then reference an event group. That was the thing that we saw a bit earlier, actually this one, right? The event group that defines on how your events look like and which data you can put into the payload. And this is basically what brings your component self-dispatching actions. So it's not necessary like with the full NGRX store anymore to call this store.dispatch and pass an action in and this action as a payload. No, it's easier. It's just using the action itself, passing the payload in, and it's automatically dispatched. That's the new API of self-dispatching action that you can easily create by just using instead of a direct import of the events and the dispatcher separately. You can just use inject dispatch, and then it's fully covered to just call the function and the action gets dispatched. That's quite nice. Fine. So I want to show you also a quick, before we close the demo and then go back to the Q&A session. Just give me a second. I want to show you a very nice usage of the Event API. Just one moment. my state report that actually combines together all the ideas that we discussed today. I zoom in a little bit, and then you can basically first of all find a nice store implementation in the domain folder. Wrong one, here it is. So the booking domain, once again, logic flight, and here we have the state folder with the booking store. So here's a little bit more advanced implementation. We would not have enough time to do this all in the live coding here, but you can see similar thing like I started with a filter state and basket state, usage of the entity API to manage collection of data. You initialize it with that. So the first line here, 41, is actually creating the state for the basket and the filter. That one is now creating the state for the entity collection flights. And then you can add some properties like the stream of events, or the events that get dispatched can be accessed here with the injected events. You can also inject the self-dispatching actions like you have seen on the slides before, and as well the flight service. Then I have some derived state. So if you want to have not all the flights, but maybe filtered to show only the delayed flights, that's possible here with computed, creates your derived state. And here we have some methods. We'll come back to the methods in a moment. First of all, the reducer implementation, again, like already spoiled with the slides, we listen to the filter changed action. We access a payload like the filter here, and at the end, we just patch. So patch state is not necessary here with the reducer. You just define the object, the new state object, and patch state is automatically used behind the covers. We can do so for all the other parts of the state. So here is an action for changed selection. Here is an action for an updated single flight. Here is an event for a flight collection, like an array of flights, like the server could return, and we can use a helper function from the entity package, like set all entities, right? So that's really quite straightforward and nice on how to implement that stuff. Down there are my side effects. On the one here, it works that way that we listen to all the events, and then we say we want to filter with the on statement here, with the on method, and we say we want to filter on the flight filter changed event. And only if that one is dispatched, we want to do the server call at the end. We say, in the success case, please just use another action, flights loaded, pass in the flights. And here we have flights loaded error to dispatch another action that actually can afterwards process, or based on the action, we can process the error. Yeah, it's a more higher sophisticated implementation, I would say, with using more APIs of the signal store. And then the final thing I would like to show you today is how can we use now this, hopefully also for you, closes the circle where we started with the signal forms, and how we can end here with the store implementation with events. So basically I jump back to my flight search implementation. I have a very, very lean TypeScript class. Yeah, only 2 lines of code here in the component TypeScript class. I inject my store and I inject my events. To be fair, it's not always that lean, right? But for this example, it's sufficient. And in the template, I now can use two-way binding, even with some APIs that are made available with the store. And this is actually the last remaining part that is at the moment integrating signal store solutions into your template especially. It's not that easy like without the signal store, because typically with the signal store we have the unidirectional data flow. We read from a read-only state, we take that state, and then we write back in a different way. So we need to, like before, use the set filter function, for example, right? So we always needed to use a two-way binding instead of a two-way binding, a one-way binding for property binding, and a second binding for event binding. So that it was never easy actually to just use a writable interface. And for that, I implemented a quite simple but helpful function that you can also put into your code base. It's unfortunately at the moment not available in the Angular framework, also not available in the Nginx namespace, but hopefully in future we will receive something similar. Here in the util signal package, you have such a delegate signal. So what's a delegate signal? You can see it's almost just from line 4 to line 11 with some line breaks even in between. So what does it do? For that, I, for the last time, jump back to my slides. If I find my slide deck, yeah, here it is. So how to connect forms and state management. Global state management typically uses unidirectional flow. We had this already. Reading, reading the state through a signal, but writing back through a method or by dispatching an event. And that's a thing that is harder to use in the template. Therefore, we can use maybe also state management with writable signals. Unfortunately, at the moment, not officially available. So maybe the sad emoji or the one that is not that happy with the current APIs. What can we do actually? Just to put this on one slide, we have a signal forms implementation. The signal forms implementation synchronizes with the writable signal. Yeah, we discussed this at the beginning of this webinar. Then we have a signal store here. That's kind of our box, our container that manages the state and side effects. And now the question is, how do those parts come together? Basically, we have a read-only signal for the state, and we have an updater function to work into the opposite direction of updating the state. Then we could use in the middle the delegated signal where you just saw the implementation. And this delegated signal is just a kind of a proxy implementation, right? That offers the writable interface for our forms API and delegates in the background, so connects the readable signal state and delegates back to the updater function. So by directly thinking about this concept, we have from the public surface on how the template is using it, just a normal writable signal. Also the forms API just wants to have a writable signal, that's all. So what do? We give the forms API writable signal as a delegated signal behind the covers. It reads one specific signal of the store and writes back to an updater function that has the same typing. That's all, right? That's all what is also present here in the code base. A simple generic function, I just call it delegated of a specific type. It can actually use a signal, so that signature is also fulfilled by the signal, a function that returns a type if you invoke it. And then on the other hand, I have a second argument, the setter function, where you can pass in the value, and actually it's just a fire and forget, so nothing is returned. And what is returned by this delegate function is a writable signal. And as mentioned, each writable signal can be used with the forms API. So now we have you fully covered. You can easily connect your signal-based state management based on the signal forms API with the other signal-based state management, the signal store, and all you need to have is a few lines of code more. Yeah. Let me quickly show you the usage of that API, and then we're done. So going back to our store, just one moment. That's the mysterious method section here. You could also use a with props section, but as I also have some factory functions here, I used it in the with method section. So I could create my writable filter like that, delegated, use my read-only filter, and use the action or the event, in this case, the self-dispatching event, flight filter change. That's all. And then you have a public surface that you can also use in your template. So jumping back here for the very last time into your template, you have here a two-way binding, even from the child component, right? Two-way binding on the filter, input-output combination here, and it uses your writable filter. Down there, I iterate over my flights. I can even create some local template variables, and this is where my factory functions come into play. So here I want to directly within my for loop say, hey, I would like to have an updater signal, an item signal, where the flight card just could basically bind the flight for reading the flight from the parent component, in this case from the store, and the child component can then do an update, and this update is automatically processed by this let variable here. Same for the basket selection. So even if you have a complex object with such a factory approach, you can say, I just want to create one single signal for create basket selection and pass in the ID. So then it's automatically clear what I want to use. So which ID I want to update, that's all. And the whole component implementation now is a bit easier by using writable signatures directly. And that's made for parent-child communications. So yeah, just an alternative that you can think of using. If you don't want to use that, just stay with the classic approaches, calling methods and reading signals. That's all for today. I hope that was interesting for you. So I pass the floor back to Manfred.
Awesome. So big thanks, Mikey, for this awesome webinar. So before we go on with all the open questions, I want to show you and especially the audience something we have for them. So now you should see my browser. And now let's go at this website, Angular Architects. Perhaps you've heard about it. And if you go to the English version and scroll down, then you find here something that's called Modern Angular Architectures with Signals and the Resource API. That rings a bell, I guess. Do you know this workshop, Mikey?
Oh, yeah, that sounds very nice, right?
So if we go in there, we see, well, it takes place in December, on December the 4th. And if we go down, we see here Mikey, and we see the agenda of this entire workshop. It's an online workshop, and it's about all the stuff modern Angular with a huge focus on signal forms, the NSHRX signal store. So do you want to tell us a bit about the agenda we see here?
Yeah, definitely. It's basically, I guess, a good chance to get updated actually with all the recent changes in the Angular framework. I already mentioned this at the beginning. Sometimes it's a bit hard to maybe go from the excitement, being happy about all the new features that we received, to a clear plan on how to refactor our own code bases. And that's the aim for this workshop. Yeah, giving you some guidance with a lot of live demos on how to do so. Right, integrating signals is not that easy compared to just turning an ng statement into an add syntax with the control flow. So basically, yeah, I'm very motivated telling you even more because we just had 1.5 hours today. Of course, with the workshop, we have more time to go deeper into all the APIs and strategies on how to work with them.
Sounds interesting. Sounds interesting. So for instance, here we have one chapter about data binding, which also touches on zoneless. We have a chapter on interop with RxJS, and I think it's a good spoiler, but RxJS will not go away, even though Angular will make it optional, but usually we will need it for stuff that is a bit more complex. That's why we need the interop story. And we also have a lot of stuff concerning signal forms and state management here.
Yeah.
So
exactly.
what's your favorite topic, Michael, in here?
I would say that exactly what we covered here in the workshop to really come back to the very first part, signal forms at the moment. I would say I also love the other parts. I hope this was transparent throughout the whole webinar. The signal store API, the signal API itself. Also tiny APIs like the component input bindings, right? It's a complete new way on how to implement our applications that way.
Yeah, totally. So yeah, as mentioned before, it's from December the 4th to December the 5th, and it's full 2 days. And yeah, So make sure you save your ticket. Okay, so now let's go back to all the questions I have collected.
Fine, great.
So I start some of them. I already answered some of them, but let's have a look at the most important ones. For instance, this here. How can we make form fields depend on each other? For example, when a specific value is entered in one input, another input should automatically become read-only.
Yeah, therefore we have really a function like we used before with required for read-only. So it's really called that way, read-only. We also have this for disabled and for hidden, for example. So that's a way on how to monitor and get notified of form status or form state. And if this state changes, we can do something. What is also quite interesting is maybe you have a value inside your form. If the one value changes, you also want to automatically notify another form field. And the nice thing about this is we are already working with a reactive API. So it's signal based. You can use the reactivity based on the value. And on the other hand, we also have this implementation block in the schema. So to be 100% honest, we need in this very corner of the implementation a bit more guidance from the Angular team. You also will have the chance to meet the Angular team next week at the NG Poland in Warsaw, or also book an online ticket maybe. And I guess we will get furthermore guidance on also what they have in mind for the future. So it would be very nice to also have a quite nice convenient API on how to monitor one value to change another one. Technically, it's already possible because we are talking about signals, right? It's just a question what is the recommendation, where to put it best into the schema somewhere else, but it works already. Yeah. There's even maybe as a follow-up answer, not question, sorry. We even have the chance to add master data. So you could react on the state change. And maybe if one field changes, you want to add a property, that's also technically possible to one of your metadata fields. And maybe that property contains a collection of customer names, yeah, that you want to show in an autocomplete. Also, that is possible already.
Perfect. By the way, I almost got used to the echo you are sending.
Sorry for that. Really
No
sorry
worries,
for
no worries.
that.
But until the workshop, of course, we will get this settled. So I think
Definitely,
we will look
definitely.
into it afterwards, after this webinar, to find out what's going on here.
Yeah, maybe it was really like you expected at the beginning that my microphone has an issue. I'm very happy with this one since already some years, but maybe it's end of life. I will figure this out. Sorry for the bad quality.
No worries, no worries. Okay, cool. What's with the bouncing signals?
Yeah, the bouncing signals is an interesting story because we have no RxJS directly. I know a guy, you can find him the left side of my camera picture, who wrote a nice function for debouncing. Later on, also Alex Rickable from the Angular team showed a snippet on social media. But there are also alternative ideas where we say maybe it's not the signal that we want to debounce, sorry, but we kind of could use this on the level of the event binding and not have a click event listener, but a click debounce 1 second, for example. Yeah. There are even other possible ways to go with a normal smart component, dump component architecture, where you can use the dump components to basically create something similar like debouncing. I'm happy to show you that one in more detail in the workshop. But the idea is basically if the child component is only dispatching the event a bit later, then maybe that's already quite close to debouncing. And of course, you can always use the RxJS in top. That's also a possible way to go to just use the debounce operator. Yeah.
Awesome. So a closed question, is the same expressiveness power of reactive forms guaranteed with signal forms?
Just a second to fully get the meaning. Is the same expressiveness power of reactive form? Yeah, of course, of course. Yeah, to be honest, the name reactive forms might have been a bit misleading. So reactive forms were not always that reactive, like the name indicated. To be honest, we had some observables, but not everything was reactive. I would even say with signal forms, far more, almost everything is reactive, and that's of course good for performance. Validations can happen quite often because of users typing quite fast, and therefore I would say it's even superior compared to reactive forms if it comes to the power of reactivity. Yeah. Great photo, by the way. I had a funny one on WhatsApp the last days, but my daughter forced me to remove it with a serious one. Yeah.
Awesome. So is there a replacement for control value accessor with the new forms?
Yeah, that's also a very good question, Alan. Nice thing, control value accessor. I saw this pattern, to be fair, quite often now from the Angular team, that they offering new APIs and then making fun of their previous implementations, because now they can be open freely as they have a better solution. And that's maybe also for the control value access, right? So like with the control flow in the past, some Angular team members mentioned, hey, to be fair, it was not always easy to implement all the structural directives and to really remember how they needed to be implemented. And this was kind of relieving for the whole community, because people thought, okay, it's not only us, it's also the Angular team struggling with some of their own APIs. And I would say the control value accessor is the new running gag, let's call it that way, because with signal forms, also the story of implementing the control value accessor becomes far more easy. You don't need this interface anymore. We have the schema concept and others on how to basically also have a split form implementation, part of in the parent component, part in the child component, so the story gets easier. Nevertheless, the control value accessor is still here in third-party packages in your own source code, and the Angular team is striving for compatibility in this area, right? So that you can use control value accessor implementations still in combination with the new signal forms, but for the future you have leaner, simpler APIs on how to implement the same concept without a control value accessor. Yeah.
Perfect. Perfect. Why did you put the validation schema outside of the component class?
Yeah, good one, good one. I saw you were following my live coding closely. That's good. Yeah, it's basically your own choice. It's not connected in this case to dependency injection. You're free to just put in a generic typing like I did for the passenger. So putting it in line is an option, but putting it into an explicit variable, maybe even outside of your class, allows you exactly what was part of the previous answer, that you can pass this around and even use schemas across different components. So that allows you the easy integration instead of the control value accessor, or at least it is part of them. Yeah.
Cool. So what's with SOT integration?
Yeah, good one. We have actually support for a standard schema, and SOT fulfills that API. That means you could, instead of this schema definition that I showed you in the live coding, also use present implementations available from the community. SOT is one of that, because SOT is quite popular. You also use it in a lot of AI APIs like the OpenAI ChatGPT API and so on. So many people are know on how to write a SOT schema actually, and the Angular team also makes this possible for signal forms. Yeah.
Awesome. So why do you use a signal store and not just an injectable like a service with signals?
Yeah, to be fair, I just showed an opinionated way. Doing forms implementation even without the signal store is of course always possible. It's just a third party, a very popular one already. But nevertheless, injectable-based state management is still an option if you have not that complex global state, and at injectable is quite fine. Although the Angular team or the Google company itself is not using NGRX each and everywhere. Parts of the projects are using NGRX, others not. So at the end, it's your choice. I would use the signal store if I have an enterprise applications where I also strive for having similar implementations within my developer team done by different developers or even across developer teams. If you want to have quite similar approaches and concepts on how to implement stuff, of course, a ready-made state management solution gives you kind of a guidance on how to do so. Yeah, so there's nothing wrong about that injectables, but I would say it's easier to scale with a proper enterprise state management solution. But if you are happy with your injectable-based state management inside your Angular app, no need to switch. Yeah.
So is there really a need for events, the Redux pattern, when it comes to applications that are vertically split into domains, micro frontends?
Yeah, very good question, and maybe similar answer like before. Yes and no, it depends who you are asking. If you ask me, I'm a huge fan of the Redux and the Flux pattern. If you ask other colleagues of our network, Angular architects, there are also a lot of people happy about lean state management solutions. There's nothing wrong about this. I would also say don't force yourself, don't force your team into a complex state management pattern if not everyone knows about the details on how to apply this, because then likely the code quality will suffer and you will not have fun implementing that stuff. But if you really like those patterns and if you like the way of message-based APIs like Flux and Redux are using, then basically the signal store has you covered. The nice thing is you can start with the lightweight approach, or even like we had it before with a net injectable. Then maybe one day, if you want to have more reactive APIs automatically available, you could use the lightweight signal store directly. And only in those areas where you say events could give me an additional benefit because I want to connect 3 different stores based on one event that I dispatch, then the event API can be simply added to only 1 or 2 or 3 signal store instances, and the rest of your 20 signal store instances stay without the event API. That's perfectly fine. And even the author of the signal store, Markus Daniverovic, showed a similar pattern at the recent conferences in the US and also Germany.
Cool. So someone did not really like how the signal store
Yeah, that's
looked
fair.
like.
That's fair.
But perhaps we can reframe this question. Why does it look like it is currently looking? And what's the benefit of this? What are the ideas behind the current design?
Yeah, I like that, Manfred. Yeah, putting it. Although I would say also that the question was not. Although we have ugly here, it is definitely a question that is valid, right? But on the other hand, to rephrase it, maybe to also think of talking about why the API decision was done that way. We have a quite functional API. It's not class based on how we implement our signal stores. Although there is one guidance in the documentation on how you could also implement a signal store inside a class, but to be fair, most implementations look similar like the one that I did, very functional with nested features, and it gives you a very nice benefit. Each and every with function that I implemented or used in the live coding is most of them were directly imported from the NGRX signals package, some of them from secondary entry points. But guess what is always possible? You can implement this function out of your own repository, out of a third-party namespace. For example, we offer the NGRX toolkit package that gives you some additional APIs that are generic and make things easier, like undo, redo, the Redux dev tools, and so on and so forth. So at the end, the signature that we have in place right now, the composition style that it offers with these functions is a nice one to be really very nicely extendable with your own code, with your own generic features. Yeah.
Cool.
And I promise you get used to that quite fast. Yeah, that's you're very easily into that in a few days.
Yeah.
Maybe, I would say.
We are all creatures of habits, so if you
Yeah,
use it for 1 or 2 days, then it will come naturally for you. So people like the code for the delegated signal. We will send out tomorrow in the morning everything,
fine.
and
Yeah, great.
then you will get the stuff.
Yeah, and maybe then we start to promote this to bring it to the NGRX namespace or the Angular one. Yeah, I hope this will happen. Yeah, or the Angular team has, I guess, some APIs in mind that could go into that direction. Yeah.
Can you create a signal form using a type instead of a concrete object, something like form of user?
Passing in generic information is definitely fine, but you need to pass in a writable signal. That's important because the signal store needs to have the data model to read from and write to, but generic information is fine. Yeah.
Cool. Then another question, what's with the facade pattern and the new signal store? Do we still need it? Do we still recommend it?
Yeah, that's possible actually. So facade patterns help you to make the access to the store maybe a bit easier also for developers that don't know about the details on how to implement the signal store in general with maybe also RxJS in mind, or you could also use the facade pattern for implementations where parts are using the signal store, others are using the full-blown NGRX store, and there are some injectable-based approaches and maybe some components that are using data access services directly. But you want to have a common facade in this way that your components also have always have the same strategy on how to access state and have the whole view model, including update functions available, right? It also helps if you have a team where not everyone has the same skills, actually, maybe some junior developers next to very advanced Angular developers and maybe some backend guys that do not implement Angular stuff that often. Again, in combination with the full advanced Angular guys with all the reactive patterns in mind. And then the facade could be your boundary where people can easily implement the view layer without any burden, but the reactive parts that maybe are still using RxJS, they can be implemented by the more advanced guys, and the facade can help you. Yeah, so definitely a good idea, not mandatory, but brings some advantages.
There is a nice reaction on this. Someone said a signal store is already its own facade. So
maybe
is it too much, or is it okay, or does it depend?
Yeah, I would say it's still okay to have a facade, especially for those reasons where you have a not the same strategy in each and every area. So like for different state management implementations. But yes, I also agree, signal store can be regarded as a facade, and as you've seen, you can also use private properties with an underscore that are not exposed. And I would even take one step further. Let's look at the delegate facade once again, right? So also our writable signals could act as a facade because you know from an outside perspective it's just a writable signal and you don't even know that you're using a store, right? That's also kind of a facade pattern applied directly with the delegated interface. Yeah.
Okay. Awesome. So I think that's it. So once again, Michael, big thanks for all your insights. Also to the
Thanks a lot.
audience, big thanks for joining. And yeah, if you like these topics, then please remember Michael's workshop in December.
Great. And I remember to check my microphone. Sorry for that.
Yeah.
Thanks a lot.
Awesome.
Bye.
See you around.
See you.